So I'm Daniel. I'm from a company called ProductBoard, and I will tell you something about Webpack and React.router, because those are two technologies we love to use. They work well with universal apps, and I will cover some basics. I will tell you why we love them, and as well some more advanced tips and tricks how to use them with more complicated setups. I will start with Webpack. How many of you are using Webpack right now? Can you raise hands? So not that many. That's interesting. So what is Webpack? Webpack is essentially a module bundler, kind of similar to Browserify, but the biggest difference is that the main goal here is to manage all your static assets. It's not just for JavaScript. You can use it for images or style sheets as well. And the goal here is to take all your dependencies and bundle them together so that your users, your clients, doesn't have to do hundreds of requests to get all the dependencies they need to run your web application. So they can do just one request and get the whole app and use it. There are several reasons why we love it. First, it doesn't matter what module system you are using. It doesn't have to be just CommonJS or AMD. It can be even like ES6 imports. That's the first thing. Second thing I've already mentioned are that you can use it for all types of files. This is done through Webpack loaders. Webpack loaders are kind of preprocessors for your files that compile different types of files into JavaScript. So you can use it either to get your, for example, CoffeeScript or ES6 files into JavaScript that works in all browsers. But you can use it, as I already mentioned, for CSS and images as well. So how does it work with CSS and images? This is an example of React component, how you can use it. You can, into your JavaScript code, you can import those files, which might feel weird at first. So what will happen if I will import the image into my JavaScript file? And actually, a couple of things can happen. It depends what loaders are you using. This is an example. For example, if you import image, two things might happen. First, your image will get compiled and fingerprinted, and you'll get the correct URL. Or it might get converted in base64 string you can use directly in your component. For style sheets, you have even more options. Either you just declare that your component depends on this piece of CSS definition, and you don't get anything back, but the Webpack will make sure that this CSS will get included into the final bundle. And then you can either have it in one huge file, or you can extract it into a separate file with just CSS as well. And of course, the CSS doesn't have to be just CSS. It can be Sass or Less or whatever. You can use whatever preprocessors or post-processors you are used to use. So this is awesome. Second reason why we love Webpack is that there are a lot of different plugins that you can use to have more advanced build steps. For example, you can use it for different code optimizations, like uglifying your JavaScript or compressing the final bundle. Or you can use it for different custom tasks, like uploading stuff on Amazon F3 and stuff like that. Third reason why we love it is that you don't have to just build one huge file at the end. You can split your app into multiple parts, multiple chunks. This is awesome if you have larger single-page application that consists of different screens, and you don't want your users to be downloading the whole JavaScript for all the screens if they are visiting just one. This was one of the reasons why Pete Hunt from Instagram originally started using Webpack for Instagram, because they didn't want users coming to just like the stream of images or specific user profile to be downloading the whole JavaScript for the rest of the application. So what Webpack does for you is that you can define different entry points, which are essentially the different screens in your app where the users can go, and Webpack will build different chunks with just the JavaScript that's needed for this specific screen. And then using this Webpack Commons chunk plugin, it will figure out what parts of the code are shared across different screens, and it will bundle them to separate chunk as well, so your users are not re-downloading the shared code again and again if they are going across the screen. So for example, if you have React as a dependency, your users will download it just once at the beginning, and if they are going to different screens, then they will just download the new code that's needed to render the next screen. So that's pretty awesome, and that can help you with initial render as well. And the last big reason why we love Webpack so much is that there is this Webpack dev server, which is essentially like a little node server that runs locally and that builds in memory all the assets for you, and has this great functionality for hot module replacement. So if you save your file, you can instantly see the changes in your browser without needing to reload the page. But what's great is that all your state of the app stays the same, just the one module that you've changed gets pushed through WebSocket to the browser, and the new code can be used. So that's awesome. Some of the best practices we learned using Webpack. First, that the bundle splitting is really awesome, and you should all use it if you care about how much stuff your users need to download when they are visiting your page. It's great to use it for all the assets, because then you are getting all these benefits I've talked about. You get the benefits of bundle splitting for CSS images as well. You don't have to be creating your own sprites, because Webpack will do that for you. For CSS, what's our experience is that for bigger projects, CSS modules is great technology, how to do it, but if you are doing something smaller, it doesn't matter that much. And that the hot module replacement, it's a huge productivity booster for developers. In Webpack, you can do so much stuff that you don't really need to be using Gulp or Grunt anymore. You should be able to do everything just in Webpack. So we are usually using just npm run or bash to start the Webpack builds. Okay. Some more advanced tips you might never heard of, because although Webpack is so awesome, the documentation isn't really that great, so it's hard to figure out what's really in there. First thing I think is really interesting is Webpack Resolver, which is essentially the functionality that figures out what file to use if you are importing something. There are some parts you can configure. For example, you can configure the root for your import. So if you are using absolute links, then you can say that you don't have to be writing .. You just can specify where the root of your application structure is. But the second thing, maybe more interesting and exciting, at least for us, is that you can define default extensions for your files. So you don't have to be requiring everything .js. You can say this is default extension, and you just write the name of your component. But you can do much more with this. What we are doing at ProductBoard is that we get inspired by how in React Native, you have different versions of your React components for different platforms, for example, for Android and iOS. We have different builds ourselves. It's not for different platforms, it's for different user roles. And with Webpack Resolver, we were able to configure the same functionality. So we have different versions with different prefixes of the extension. So it's component.admin.js. this version of the same component for admin, and then component.user.js is for normal user, for example. And you can do this just with a resolver, like you can see here. So that's pretty awesome. Second thing is this Webpack isomorphic tools, which Salvo was already mentioning. This is something you need to be using if you want to be requiring CSS and images, and you want to be using it on the server as well, because it doesn't work by default. So if you want to do universal app, this is something you should really look into. It's pretty awesome. Next thing is build performance optimization. Usually Webpack is pretty fast, but for example, our app is already pretty huge. We have more than 450 components in there, and since we are doing multiple versions of the build, it took quite some time to do it. For us, it was over 5 minutes to get the whole production build done, and that was too much, so we were looking how to improve this. What's interesting is that there is this web application from Webpack that does some analysis of your builds and can give you some hints how to improve it. We took some inspiration there, but since there is no documentation for it, it was pretty hard. Sorry. It was pretty hard to find something really meaningful in there. But what we figured out in the end is that first, generating source maps is pretty expensive. One of the most expensive things in the whole build process. But you have several options how you can generate the source maps, and there are options that will generate very nice source maps, but takes quite some time, and there are some versions that are much faster, but the final source maps are not that nice. So you can make your own trade-off here and decide to go for something faster. Second thing is that there is this no parse option that will tell Webpack for some dependencies not to go through them looking for requires or imports. So if you have some dependencies that you are sure that they don't have any more external dependencies, you can use this this flag, and it will make it much faster because Webpack won't go through them anymore. So this is essentially for any already minified dependency you are using in your project. Another pretty cool technology or library is this Happy Pack, which is essentially a plugin that tries to make you happy by making your builds faster. And it does this through two things. It has pretty good caching. That's the first thing, and it allows to run the compilation in multiple threads. So that's pretty cool. It's super simple to use it, to set it up, so there's really no reason not to do it. And with all those tricks I've already mentioned, we managed to get the build times from 5 minutes to just under 1 minute. So it was pretty successful. And if you want to know more about this, there is my colleague Tomáš here today, and he did basically all this work to get all these interesting insights, so he can tell you more if you want. Last thing, there is a Webpack 2 coming. It's pretty exciting. There will be some interesting functionality for us, especially around tree shaking and dead code removal. So, for example, if you have ES6 dependencies that are exporting different things, but you are not importing them, Webpack will by default throw them out of your final bundle, so your final bundles will be much smaller. So that's it. Now, React.router. Let me just take some water. Do you have any questions? No? Okay. So luckily, React.router is much simpler. How many of you are using React.router right now? Almost nobody? Cool. So it's a pretty cool routing library, it's a declarative way how you can map different URLs of your app to the tree of components that should be rendered. If you wouldn't be using this library, how it would work is that you would have to have some component like this, where you are listening to the changes of the URLs, and you are parsing the URLs and then deciding what screen of the app to render. And this can be pretty tedious if you have bigger app. For example, our app has, I would say, over 60 different routes, so this can take quite some time to implement all this manually. But with React.router, this is super simple because React.router, based on the configuration you've seen in the previous slide, it will inject all these things into your apps for you. So it can inject what are the child components you should render based on the current URL. And it injects all the functionality you need to do all the route transitions. So the API is pretty simple, but it wasn't that simple to get to such a nice API. There were several rewrites of the React router. I think 4 complete rewrites of the library that always came with completely different API. So we even this is just a joke, we even wanted to write a book about it, because with every new release of React router we had to rewrite our whole app. But I think current version is something like 2.5, and that's already pretty stable. So you should be good if you are starting to use React router right now. What is great to know is that React router is built on top of HTML5, History API, and History.js. History.js is pretty cool library that sits on top HTML5 History API and brings some cool stuff, for example, base name support or query parameter support, and you can do some cool stuff with it. And it's good to know this because you'll be basically using it either directly or under the hood with React router a lot. So I would recommend you to go through this library and check it out to see what's really there. So again, some basic tips and tricks. If you are building a very small application, you might not need a React router, and you might be quite okay with just History.js doing this yourselves. But if your library is bigger, I would really recommend using something like React router. What you need to make sure is that your should component updates are written correctly, because after each URL change, the information that the URL changed is going through whole your app through props, and you need to be sure that you are not just re-rendering everything again and again, but at the same time that all your links that need to be changed because they are not active anymore or something are re-rendered correctly. And what's great to do is to centralize the logic that generates the URL for different parts of your app, because if you will change the logic in the future, you won't have to go through whole your app and rewrite everything. You can split the routes definition into smaller reusable parts. So for example, if you have some detail of some entity in your app that you are using in different contexts, you can not only reuse the components, but the routes definition as well, and that's pretty cool. And I would definitely suggest you to use something like React Router Redux if you are using Redux, because then it's much easier to use. Okay. Again, some more advanced tips. First, you can use it on the server as well. You've seen already some example in the workshop later. You'll see this quite in detail, so I won't go through that as much. You can use named components, which is great for complex layouts. That's something that's hard to find in the documentation as well, so definitely check it out. There are cool hooks, how you can hook into the life cycle of routes transition. So for example, if you have some part of the app where your users are editing something and they have some unsaved changes and they are transitioning away, and you want to ask them if they are sure they want to throw out the unsaved changes or if they want to cancel the transition and save them, you can use this for it, and it's pretty simple as well. And the last thing is that, as I've already mentioned with Webpack, Webpack can create multiple bundles for your app, and it's great to separate your app by the routes, essentially the screens of your app, and there's functionality baked into the React router how to do it, because you can asynchronously fetch the routes definition as well as the components that should be rendered for these routes. There are basically two options. Either you can use those methods you can see on the slide, or there is much nicer library. It's called React.router proxy loader, and that this can do this for you with much nicer API. Okay, that's it. Thank you very much.